So with this next question here, we want to begin, as always, by reading that question first. And it says here, how far apart are the two buses? And specifically, we're talking here about 5 p.m. So at 5 p.m., how far apart are the two buses? All right, sounds good. So what I'll go ahead and do here is I'll go ahead and highlight that we're looking for how far apart these two buses are, meaning that we're looking for a distance. So we'll go ahead and mark that down right here. And when we read the context, we see that it says a bus leaves Springfield at 9 a.m., averaging 50 miles per hour. Another bus leaves the same city at 11 a.m., averaging 60 miles per hour in the same direction. At 5 p.m., how far apart are the two buses? Okay, sounds good. So my party people, when I read this here, when I see that these buses are traveling in the same direction, what can we do with their individual distances to get how far apart they are? Again, yep, because we're moving in the same direction, we can subtract. Same directions, we can subtract. We can subtract the rates and we can subtract the distances. The only reason we can't subtract the rates in this problem is simply because, right over here, they are not moving for the same time period. We see that the other bus leaves the city at 11, where the first one leaves at 9 a.m. So because of that, hey, they're not traveling for the same time period, so we cannot simply subtract those rates. What I will do, though, is I'll go ahead and calculate the individual distances and then subtract those distances at the end. So here we go. We'll go ahead and say the distance for bus 1 and the distance for bus 2. And then at the end, we will subtract those distances. So the rate that we have here for the first bus, let's go ahead and highlight that here in green, 50 miles an hour. So we have the rate being 50 miles per hour. And then we are going to multiply for what value, what time period? I see 9 a.m., I see 11 a.m., I see 5 p.m. What time period is bus A actually moving for? Yeah, and to do that, to figure that out, we have to actually understand the difference in time between 9 a.m. and 5 p.m. That's where the first bus starts and stops. So when we think about that, we can think about, hey, 9 to 5, well, that's going to be 8 hours. Or if you didn't quite know that, you can just think about, hey, 9 a.m. to 5 p.m. If you think about 12 p.m. being right in the middle, you can think about it as 3 hours between 9 and 12, 5 hours between 12 and 5, and that's what makes 8 hours, if you wanted to think about it in that way. So we have 8 hours over here, and then we have 50 multiplied by 8 hours, and that's going to give us 400. Let's move this over ever so slightly here to the bottom corner, but that gives us 400 miles. For the second bus, we have 60 miles an hour listed right over here. And my party people, are we also multiplying by 8 hours? Not quite. Here we started off at 11 a.m. for that second bus. So 11 a.m. to 5 p.m. We can think about it in the same exact manner. 11 to 12 and from 12 to 5. That's 1 hour and that's 5 hours. So that makes 6 hours. 60 multiplied by 6. And that's going to give us 360 miles. So what we want to do here is subtract. We see that the first bus ends up traveling 400 miles. The second bus ends up traveling 360 miles. And when we subtract those distances, because again, same direction, we will end up getting 40. 400 minus 360, that gives us 40 miles. And that's what makes the correct answer here. Answer choice B. And let's take a nice careful look at this first example. So let's take a nice careful look here at this first example. Right there. So my party people, first things first, we want to read the question sentence. Anytime we do a word problem, we really want to understand what the question is trying to get at, what the point of all of this is. So my party people, when we see that it says, how many miles does the cyclist travel? My party people, what does that mean? Does that mean that we're looking for distance, rate, or time, in your opinion? Yeah, we should definitely feel confident that we are looking for distance. Because when we think about the different ways that distance, rate, and time can appear, a rate and distance are the ones that get confused the most often. Now, the difference between a distance and a rate is simply the units. A rate will always be written as 2 units together. MPH stands for miles per hour. So in this particular instance, 20 miles per hour, this is a rate because it tells you how far you go in this amount of time, in 1 hour. Miles per hour. We mix those units together, and that is what gives away a rate. If we're just talking miles, or feet, or kilometers, or yards, or centimeters, those are just flat distance units. So let's go ahead and get into this here. My party people, we know our formula. We have it written down. It's going to be distance equals rate times time. So let's write that down. Distance equals rate times time. So everybody, what are we going to be replacing the rate with? Yeah, that's going to be 20. We have 20 miles per hour right there. So yeah, absolutely, we'll replace that nice and easy. So I'll just replace that there. And then my party people, for time, what are we replacing time with? 3.5, absolutely. Absolutely, there we are. So we know that the distance covered in this problem is going to be the rate multiplied by the time, and boom. So with that said, everybody, let's multiply. So here we go. We'll have 20 multiplied by 3.5. And if you're feeling a little nervous about working with decimals, this can definitely be a part where you slow down, and that's okay. But let's remind ourselves of how to work with decimals when it comes to multiplication. The way you work with decimals, everybody, well, ignore it. Just ignore the decimal. You're good. Just ignore the decimal, multiply like normal, and then bring the decimals back at the end. So let's give it a shot here. We have 0 multiplied by 5, and that's going to end up being 0. Then we have 2 multiplied by 5, and that's going to end up being 10. So we've taken care of this right here. All good. Now let's move it over to the 3. So to make sure that we start on that place value, we're just going to put a 0 right there to just blank it out. So then we'll have 0 times 3, and then 2 times 3, and that's going to give us 6. Add all of that back up, and that's going to give us seemingly 700. But my party people, is the answer going to be 700? No, not at all. Not at all. What we need to do is, again, bring the decimals back. Got to be careful there, right? We saw over here that we don't have any decimals on the 20, but we have one right here on the 3.5. We see that there is 1 decimal space that we utilized. So we'll only bring back 1 decimal place. And there we go. That's what makes our product complete. 20 multiplied by 3.5 is 70 miles. And that makes the correct answer for this particular problem A, 70 miles. Boom. Pretty straightforward. I'd say so myself. But what do you think? What's your opinion on this one?